Chapter 6.4 exercises 43 through 52. This set has to do with polar coordinates. And specifically, we're going to be converting rectangular equations to polar form. And then we have sketched the rectangular equation. Do not use a grapher. Then support your hand sketch by graphing the polar equation with your grapher. So let's go ahead and look at this. We have, this is very similar. If you look at the video lesson for exercises 35 through 42, we took polar equations and converted to rectangular form, and here we're doing the reversal. So the main things we need to remember are these. We need to know that r squared is equal to x squared plus y squared. That's a basic circle, general form circle equation. And then we need to know that x is equal to r cosine theta, and y is equal to r sine theta. Okay, so let's go ahead and look at this. Frankly, I'm going to have an easier time graphing from rectangular form than polar form, so I'm probably going to access graphing using the initial form, and then we're going to, after having changed this to polar form, solve it. So first equation we have, problem 43, the odd number problems. X equals 3. Well, x equals r cosine theta, so we replace x. I said x equals 3. I should have said x equals 2. So we say r cosine theta is equal to 2. So to solve for r, if we divide both sides of this equation by cosine theta, we have a cancellation, so r is equal to 2 over cosine theta. Now, secant theta is equal to 1 over cosine theta. So we can rewrite this equation yet again as r equals 2 secant theta. Now, as far as graphing, well, we have the vertical line x equals 2. So here's a little sketch, and at x equals 2, we have a vertical line. Okay, there we are. X equals 2. That's what the graph looks like. Now verifying by graphing using the graphing calculator, we go to, let's see, we're in a graph page already. So we go to menu, graph entry edit 3, we're going to enter a polar equation, and we're going to enter 2 times the secant of theta. We could have entered 1 over cosine theta. And then theta, we get the Greek letters here, this pi key, and then over to the right, and enter that. So we have the vertical line, x equals 2. Same thing. This time we verify that this is indeed our polar equation, polar form of the rectangular equation. Let's go on to the next odd number problem, which is 45. We have 2x minus 3y equals 5. Well, remember we have x equals r cosine theta and y equals r sine theta. So we're just going to replace in this equation. We're going to have this 2x minus 3y is equal to 5. So we're going to replace 2x with 2, and and x is r cosine theta. We're going to replace 2x with r cosine theta minus 3, and sine is replaced by r sine theta, and that's going to be equal to 5. Our common factor in these two terms is r, so we have r times quantity, 2 cosine theta, minus what times r equals negative 3r sine theta was going to be 3 sine theta. And that's going to be equal to 5. We solve for r by dividing both sides of this equation by quantity 2 cosine theta minus 3 sine theta. And then on the right side we do the same thing. I'm putting this in parentheses here. I don't think I need to anyway on the right side. So canceling on the left, we're left with r is equal to 5 over 2 cosine theta minus 3 sine theta. Now I presume that's a correct equation, but we're just going to graph and see if our graph matches. And then I'm going to draw a little XY coordinate plane down here in the lower right. And then this equation here, 2x minus 3y equals 5, if we subtract 2x from both sides of the equation, we have negative 3y equals 5 minus 2x. And then if we divide everything by negative 3, both sides of this equation by negative 3, we have y, bring this here, we're going to have negative 5 over 3, and then negative 2x divided by negative 3 is going to be plus 2/3 x. And so we have a y-intercept. This is our y-intercept, negative 5/3. So I'll put this down here kind of close to negative 2. Put some red here. Okay. And we have a rise over run of 2 over 3. So let's go ahead and put 3 here. 1, 2, 3. So rise over run is 2, so we go up 2. And then over to the right 3. So there's up 2 over 3. So you can be about here. Over 3. And so graphing, the thing will look like this. Okay. I'm graphing in red here. So we see our y-intercept down here at negative 5/3 and our x-intercept here between 2 and 3. So let's see what this looks like in our graphing calculator. Okay, we get another page. I'm going to go to, let's do this, Control I, add graph. I'm going to get menu, graph entry edit 3, graph polar 4. We're going to put 5 over, that's going to be 2 cosine theta. And we get our Greek letter theta here. And then minus 3 sine theta. Make that theta again. There we go. All right, let's see what this looks like. And yeah, same as the original graph, right? It's graphed earlier. We have this y-intercept at -5/3 and this x-intercept between x equals 2 and x equals 3. So checks out real well. Verifying that this is, in fact, our correct equation. Next odd number problem, 47. We'll make this one just a shade bigger. We have this equation, quantity x minus 3 squared plus y squared equals 9. So I'm going to rewrite this as quantity x minus 3 squared plus y squared equals 9. And so multiplying this out, expanding, quantity x minus 3 squared, we're going to get x squared. And this x minus 3 squared is going to come out like this. Okay, if you take quantity x minus 3, quantity x minus 3, and you get x squared, which I already wrote down, minus 3x, minus 3x, and then -3 times -3 is 9. So we're going to get x squared minus 6x plus 9 plus y squared. And that's going to be equal to 9. And we can subtract 9 from both sides of this equation. When we do that, we get x squared minus 6x plus y squared equals 0. And just rearranging, we can put x squared plus y squared minus 6x equals 0. Now we can replace. Remember we said x squared plus y squared is equal to r squared. So I'm going to replace this x squared plus y squared with r squared. And this -6x, x is equal to r cosine theta. So I'm going to replace with this -6 r cosine theta is equal to 0. And if we add r cosine theta each side, we have r squared is equal to 6 r cosine theta. Now we can divide both sides of this equation by r. So I'm going to work to the right here. So we're going to get r equals 6 cosine theta. Okay, let's go ahead and work this out. As far as graphing this equation, I'm going to go back to the rectangular form and draw a little xy coordinate plane. I'm going to look for the original equation. Remember, the standard form of a circle is going to be quantity x minus h squared plus quantity y minus k squared equals r squared. Okay, that's the general format. And so according to this format, we're going to have 9 is equal to r squared, meaning our radius, r equals 3. That's our radius. And then we have x minus h. So that's going to move the center of the circle 3 units to the right. So there we have our center of the circle right here at x equals 3. And this y minus k doesn't move anything. So what we have is a circle with a radius of 3. Okay, I'm going to make this in red. There's our center of our circle. And our circle is going to go like this. And the proportion is going to be somewhat off, I know, but it's going to be this. The center of the circle is at, see, it looks kind of oblong. That's because my y coordinates are more closely matched than the x coordinates. So here you have a circle, radius of 3, shifted 3 units to the right of the origin. So we go to our calculator and push Control I, add graph, and we have our equation as 6 cosine theta. So we go to in our graph menu, and we go to graph entry edit, polar 4, so 6 cosine theta. There's theta here. I hope this equation, this graph works out right. Graph, there we go. So you have a circle centered at 3, 0, and that circle apparently has a radius of 3. So looks great to me. So we're going to call this good. We're going to call this our correct solution in polar form. Polar form doesn't look hardly anything like the original form, does it? There's not a number, like you have -3 here and 6, so you just have to work them through, or unless you get so familiar with it, it's kind of instinctive. Okay, next, problem 49. Okay, similar type of thing. We're going to have r squared is equal to x squared plus y squared, and then x is equal to r cosine theta, and y is equal to r sine theta. Okay, this equation rewritten here is quantity x minus 3 squared plus quantity y plus 3 squared, and that's going to be equal to 18. And expanding out, we're going to get x squared minus 6x plus 9 plus, and so that takes care of this expansion of this quantity x minus 3 squared, and this quantity y plus 3 squared is going to be y squared plus 6y, and it's going to be plus 9 is equal to 18. And so kind of putting all these together in necessary order, we get x squared plus y squared minus 6x plus 6y plus 18, because 9 plus 9 is 18, oops, which is equal to 18. And subtracting 18 from both sides of this equation, we have x squared plus y squared minus 6x plus 6y is equal to 0. And now replacing, we can replace this x squared plus y squared with r squared. We can replace this negative 6x by negative 6 r cosine theta, and replace this 6y by plus 6 r sine theta, and that's going to be equal to 0. And if we add 6r cosine theta and subtract 6r sine theta from both sides of the equation, we're going to get r squared is equal to, we'll say, 6r cosine theta minus 6r sine theta. And if we divide both sides of this equation by r, okay, we're going to get r is equal to 6 cosine r is equal to 6 cosine theta minus 6 sine theta. Okay, and now graphing this original equation, okay, we have we have x plus 3, so that's going to move the center of the circle to 3 units to the left. And we have y plus 3 is going to move this center of the circle 3 units down. So our center is going to be right here at -3, comma -3. And then 18 is going to be equal to r squared. So r is going to be equal to square root of 18, which is going to be equal to, r is equal to square root of 9 times 2. So it's going to be r is equal to, take out that 9, 3 square root of 2. So 3 square root of 2, I forget exactly what that is. Square root of 2 is going to be about 1.4. And so 3 times that is going to be about 4.2. So we're going to have a radius a little bit bigger, 4.2. So our radius is going to be something like, it's going to be something like this circle. I don't know if it crosses the origin exactly. That's roughly what it's going to look like. And we go to Control I, Add Graph, and we're going to put our form here, which is going to be something. I think I messed up this one here. What did I do wrong here? Okay, yeah, this I put -6x. That's plus 6x, right? Plus 6x, that's my correction, plus, so that's going to be minus. So we get negative 6 cosine theta minus 6 sine theta. That should be right. Correct my mistake, I hope. So we go to menu, graph trace, polar. We're going to have -6 cosine theta it's going to be -6 sine theta. Okay, theta right there. And yeah, we get kind of the sketch I drew, right? We have the -3, comma -3 is the center, and then that looks pretty good. After I corrected this equation, it's going to be r equals -6 cosine theta minus 6 sine theta. Okay, last unknown problem is not the same type of problem. It's a word problem. The location given polar coordinates of two planes approaching Vicksburg Airport are 4 miles, comma 12 degrees, and 2 miles, comma 70 degrees. So remember, we have r cosine theta equals x, and r sine theta equals y. So if we take, for this first point here, we have, for the 4 mile plane, we're going to have r times the cosine of 12 degrees is going to be equal to x, or 4 times cosine of 12 degrees equals our x coordinate, and 4 times sine of 12 degrees is our y coordinate. And for this other location, we're going to have 2 times cosine of 72 degrees. That's our x coordinate, and our y coordinate is going to be 2 times sine of 72 degrees. So we're going to call this x1. I should call x2 y2, and then x1 equals that, y1 equals 4 sine 12 degrees. So let's work this out. We go to our calculator. We put Control I, calculator. So we have 4 times cosine of 12 degrees, and that's going to be x1, 4 sine 12 degrees, that's going to be x2, and then we're going to have 2 cosine 72 degrees, that's going to be y2, and then we have finally 2 times sine of 72 degrees. We get this. So we have x2 minus x1, so we have, we'll say 0.618, we'll go to 3 decimal places, minus, yeah, that's x2, minus 3.913, so that's going to be x2 minus x1, and then we're going to have 1.902 minus 0.832. Okay, and just taking the square root here, we're going to take square root of, we're going to have quantity negative 3.295, that's x2 minus x1 squared, plus we're going to have this 1.07, I'm going to put Control A and S for last number calculated, squared, we get this number here. So we get about 3.46 miles, or 3.464 miles. So distance, okay, equals, say, x2 minus x1 squared plus y2 minus y1 squared, and distance is approximately equal to 3.464 miles. And the book got this same answer, except they rounded to the nearest 2 places. I went to 3 places, but that's their distance apart. Anyway, that's all the odd number problems in this set. Good luck with your even number problems, and thanks for viewing.